Question 2. Consider the function f of x equals e to the power of cosine 2x, where x is greater than or equal to negative pi over 4, less than or equal to 5 pi over 4. Find the coordinates of the points on the curve y equals f of x, where the gradient is 0. Gradient is 0. We need to figure out f prime of x. Then we make it equal 0. F prime of x equals e to the power of cosine 2x prime. Don't forget the chain rule. E to the power of cosine 2x, negative sine 2x. Then 2x prime is 2. So we get negative 2. E to the power of cosine 2x times sine 2x. We do know e to the x power always greater than 0. So we will make this equal to 0. We can get sine 2x equals 0. Let's draw this unit circle. 1, 0, 0, CST. Negative 1, 0, 0, CST. 0, 1, undefined, CST. 0, negative 1, undefined, CST. So this sine is 0. Sine is 0. This is 0. Here is pi. This is pi over 2, 3 pi over 2. So we got 2x equals 0 plus 2k pi, or 2x equals pi plus 2k pi. Divided by 2 both sides, we got x equals k pi. From here, we got x equals pi plus 2k pi over 2. X equals k pi. We can make a k equals, check here, domain, negative 1, k equals 0, k equals 1. X equals negative pi, x equals 0, x equals pi. Then k equals 2, x equals 2 pi. Cross out this and this. We got x1 equals 0, x2 equals pi. Now from x equals pi plus 2k pi over 2, k equals 0. We got x equals, substitute a 0 for k, we got pi over 2. Then k equals negative 1, x equals negative pi over 2. K equals 1. We got x equals 3 pi over 2. Check this domain. We cross out these two. So we got 3 solutions. We got x1 equals 0, x2 equals pi, x3 equals pi over 2. we need to figure out the coordinates of the points. We know the function f of x equals e to the power of cosine 2x. Therefore, f of 0 equals e. F of pi equals e to the power of cosine 2 pi equals e. F of pi over 2 equals e to the power of cosine pi equals e to the power of -1, which is 1 over e. So the coordinates will be 0, e, pi, e, pi over 2, 1 over e. B. Using the second derivative at each point found in part A, show that the curve y equals f of x has 2 local maximum points and 1 local minimum points. We need to use the second derivative. We do know f double prime of a greater than 0. Concave up. We will get local minimum at x equals a. F double prime of a less than 0. Concave down, which means local maximum at x equals a. We got 3 points, 0, e, pi, e, pi over 2, 1 over e. We also know f of x equals e to the power of cosine 2x. And f prime of x, we already figured out e to the power of cosine 2x times negative sine 2x, then times 2, which is negative 2 sine 2x times e to the power of cosine 2x. Now, f double prime of x equals negative 2 sine 2x times e to the power of cosine 2x prime. Let's work out this first. Sine 2x times e to the power of cosine 2x prime sine 2x prime times e to the power of cosine 2x plus sine 2x times e to the power of cosine 2x prime. Work this out. Cosine 2x, do not forget chain rule, times 2 times e to the power of cosine 2x plus sine 2x. We already figured out this prime equals this, which is negative 2 sine 2x times e to the power of cosine 2x. Organize. Equals 2 cosine 2x times e to the power of cosine 2x minus 2 times sine squared 2x times e to the power of cosine 2x. Then we times -2 so that we can get f double prime of x equals times -2, which is we will do distributive property -4 cosine 2x times e to the power of cosine 2x plus 4 sine squared 2x times e to the power of cosine 2x. Now we do the substitution. F double prime of 0 equals -4 times e plus 0 equals -4e less than 0, which means the graph concave down. So local maximum at point 0e f double prime of pi equals -4 times 1 times e plus sine squared 2 pi will be 0. 0 equals -4e less than 0. Concave down. So local maximum at the point pi e. F double prime of pi over 2 equals -4 times cosine pi times e to the power of cosine pi plus sine squared pi will be 0 equals -4 times cosine pi is -1 times 1 over e, which is 4 over e greater than 0. Concave up. So local minimum at pi over 2, 1 over e. So we already figured out the curve y equals f of x has 2 local maximum points and 1 local minimum point. Sketch the curve y equals f of x for x greater than or equal to 0, less than or equal to pi. Taking into consideration the relative values of the second derivative found in part B, we know 0e and pi e both local maximum. Pi over 2, 1 over e is a local minimum. F of x equals e to the power of cosine 2x. X, y, here is 0. Pi over 2, 1, 2, 3. We do know e is approximate to 2.72. So you can label this is e. 1 over e is approximate to 1 over 3, which is 0.3. Plot these 3 points. 0e is here. pi e is here. Pi over 2, 1 over e is here. Then we can sketch the graph like this. Let's go to D1. Find the Maclaurin series for cosine 2x up to and including the term in x to the fourth power. We are given cosine x equals 1 minus x squared over 2 factorial plus x to the fourth power over 4 factorial minus and so on. So cosine 2x equals, we will change every single x into 2x, 1 minus 2x squared over 2 plus 2x to the fourth power over 4 factorial is 24. Organize 1 minus 4x squared over 2 plus 2 to the fourth power is 16. X to the fourth power over 24 equals 1 minus 2x squared reduce 2x to the fourth power over 3. Let's go to D2. Hence, find the Maclaurin series for e to the power of cosine 2x minus 1 up to and including the term in x to the fourth power. E to the power of cosine 2x minus 1. We will do the substitution. Substitute this for cosine 2x. E to the power of 1 minus 2x squared plus 2 over 3x to the fourth power minus 1 minus, combine like terms, we got e to the power of negative 2x squared plus 2 over 3x to the fourth power. We do know e to the x power equals 1 plus x squared over 2 factorial plus x to the third power over 3 factorial and so on. Therefore, we got e to the power of negative 2x squared plus 2 over 3x to the fourth power. Every single x change into negative 2x squared plus 2 over 3x to the fourth power, which is 1 plus negative 2x squared plus 2 over 3x to the fourth power plus negative 2x squared plus 2 over 3x to the fourth power squared over 2, and so on. Organize 1 minus 2x squared plus 2 over 3x to the fourth power plus 1 over 2. Negative 2x squared will be 4x to the fourth power. This one squared go to x to the 8th power. These two times each other, we got x to the 6th power. We only need x to the 4th power. So we stop. Organize 1 minus 2x squared plus 2 over 3x to the 4th power plus 2x to the 4th power here, and so on. Then combine like terms. 2 over 3 plus 2 times 3 over 3, which is 8 over 3, equals 1 minus 2x squared plus 8 over 3x to the fourth power, and so on. This is e to the power of cosine 2x minus 1. D3, hence write down the Maclaurin series for f of x. We do know f of x equals e to the power of cosine 2x. We do know e to the power of cosine 2x minus 1 equals 1 minus 2x squared plus 8 over 3x to the fourth power, and so on. Left side, we can write down e to the power of cosine 2x over e equals 1 minus 2x squared plus 8 over 3x to the fourth power, and so on. Therefore, f of x equals e to the power of cosine 2x times e both sides equals e minus 2ex squared plus 8 over 3ex to the fourth power, and so on. Let's go to e. Use the first two non-zero terms in the Maclaurin series for f of x to show that this is approximate to 149e over 1500. Integral from 0 to 1 over 10 of e to the power of cosine 2x dx equals integral from 0 to 1 over 10. We need to use two non-zero terms, which is e minus 2ex squared dx equals ex minus 2e times x to the third power over 3 from 0 to 1 over 10. Ex minus 2 over 3e x to the third power from 0 to 1 over 10. Substitute 1 over 10 for x first. 1 over 10 e minus 2 over 3e times 1 over 10 to the third power is 1 over 1000. Organize. Denominator is 3000. Numerator 300e minus 2e equals 298e over 3000. Reduce 149e. Reduce 149e over 1500.